Even though the poles of Mars are quite interesting, mainly because beneath a thick layer of dust, rubble and frozen carbon dioxide, aka dry ice, lies H2O, or water ice. In my opinion, the Hellas crater is even more fascinating. Not only could it also contain a significant amount of water in the form of ice, but as the deepest point of the Martian surface, it could potentially harbor liquid water, at least for a very brief period of time. But let's start with the basics. The Hellas crater is one of the largest impact craters on Mars, with a rim roughly 2 kilometers high and a depth of up to 9 kilometers. On average, it's about 6 to 8 kilometers deep. That makes it not only deeper than any edgy Instagram post, but also a geological anomaly. That's because the southern hemisphere of Mars is generally dominated by highlands, while the northern hemisphere is mostly made up of lowlands. Kind of like the opposite of our own Earth, where most of the elevations are in the northern hemisphere, in the form of continents. Now, the crater, which is believed to be about 4 billion years old, is also massive in size, measuring 2,300 kilometers or 1,400 miles across, making it almost as large as the continental United States. But what makes the basin really interesting is the possibility that it could support liquid water, at least for a very short period of time. Now, Mars has an extremely thin atmosphere. On Earth, atmospheric pressure at sea level is about 1000 millibars. On the summit of Mount Everest, the pressure drops to about 300 to 350 millibars, about a third of sea level pressure. And that's already a death zone for humans without an oxygen mask. And even with one, it's extremely strenuous for our bodies. And then there's the so-called Armstrong limit at 63 millibars, or 6.3% of sea level pressure. And saliva, tears, and even the water in your lungs start to boil at body temperature. Not exactly ideal if you like surviving. So in short, below 63 millibars, water boils and vaporizes instantly. Now on the Martian surface, the average pressure is just 6 millibars. So water vaporizes instantly. It can't even exist as a liquid. And this is because the triple point of water, where ice, liquid, and vapor can coexist and constantly shift into one another, is about 6.1 millibars. That means Mars' average pressure is too low for liquid water to even exist on the surface. And if water ice becomes warm enough to melt, it just turns into water vapor instead of melting into water. But inside of the Hellas crater, because it is so deep, the pressure is about double of that of the average Martian surface, around 12 millibars. Yes, that's still deadly unless you're Dr. Manhattan, but it's enough for water to exist in liquid form, at least theoretically. However, it's still extremely cold, so the water would have to be saltier than your average League of Legends player to remain liquid. And indeed, there are signs that liquid brines might briefly flow in the crater if temperatures and season allow it, even if it's just for a very small amount of time. Because there's another problem for liquid water. For while on the shores of Earth's Death Sea, which lies below the ocean level and is therefore protected by a thick atmosphere, making it hard to get sunburned there, and generally speaking, while our own ozone layer actually protects us and our water from the intense and molecule-smashing radiation of the sun, Mars' atmosphere is still too thin to block the sun's high-energy radiation. And Mars has no ozone layer either, like Earth, that protects it. In other words, solar radiation on Mars can break apart water molecules, turning them into hydrogen and oxygen, meaning even if your water is cold enough that it doesn't boil, warm enough that it doesn't freeze, it would still be vaporized, because it would be broken up into two gases it is made of. And therefore, even if humanity would create an artificial lake in this basin, it would not be able to exist for long. Still, the mere fact that the Hellas basin may contain water reserves, that it lies deep enough and could theoretically host salty, anti-frost-rich liquid water, even just for short amounts of time, is still a huge deal. Also below the surface the pressure is even higher, and the water is shielded from the solar radiation, and that means there could be salty wet sand underground, which might be extracted like oil, either naturally under its own pressure or through techniques like fracking, should Mars ever be settled. And with that said, that's my little excursus into the deepest point of Mars and its potential. And with that said, now it's your turn. What do you think of the Hellas basin and the fact that Mars might still support liquid water, at least for a very brief period of time? Let me know it down in the comment section. And while you type, I say thank you very much for watching and have a nice day.